Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and/or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
All right, hello everyone, and let me welcome you to our today's session brought to you by the Oxygen Alliance. My name is Victor Mzende, a biomedical engineer with the Oxygen Alliance, and I'm excited to host this call today. I'm joining this call from Lilongwe, Malawi, and I would like to know where you're joining us from by typing your name and location in the chat. And just a reminder that if you want to be added on our emailing list, please also attach your email in the chat as well, so that you can receive communications and updates from Oxygen Alliance. I'm excited today to bring you, to introduce a new topic on our ongoing theme on the management of medical equipment, and this topic is on the management and technical details of endoscopy technologies. And it's my pleasure to introduce to you our presenter today from Kenya, who is Engineer Jim Entao, who is a biomedical engineer. And just to let you know and to encourage you, please take questions on a paper and maybe write them somewhere else, so that at the end of the call we can address your questions through our presenter. Without wasting much of your time, let me hand over you to our presenter today, who is none other than Jim Entao. Over to you, Jim.
Yes, thank you, Victor, and I welcome each one of you here. Yes, so what we are going to look at today is we are going to focus on endoscopy technologies, and so I hope you guys pick something, and maybe I'll also learn something from you guys. So let me just dive in straight away. Yeah, so when we talk of endoscopy technology, we are talking about the kind of technology that we use to visualize and diagnose conditions which are within the body, internal organs, and cavities. So this kind of technology uses what we call endoscopes. These are the actual machines, and the doctors use them to examine. They can use them to pick biopsy samples. They can also use them to do minor surgery procedures. These are usually procedures which don't require much invasiveness into the body. So this technology employs greatly the use of videos. So endoscopes use cameras which act as our eyes when they are inside the patient. So we employ what we call monitors, and this is where we can visualize, or we can see what's going on inside the body. So we have different categories. We have what we call capsule endoscopy. Capsule endoscopy is it's a very small capsule. It's like a drug. So you swallow it, then it will move through the whole of your digestive system. You will excrete it normally, and as it is doing so, it's able to take pictures, and these pictures are recorded, and the doctors can use them for diagnosis. So they say that this is better than it's not better. It is it is able to access more areas than the traditional endoscopy. So traditional endoscopies, there are two. We have the rigid endoscopy, which is whereby we employ what we call a telescope. It is rigid, and it uses lenses and cameras to visualize inside the body. We use this for surgical procedures, minimal ones, but yeah, they are more of surgical procedures. Then what we have what we call flexible endoscopy. These are the long ones. Just like the name, they are flexible, and they have a camera. They have light source. This is usually at the tip, and This is what we use to visualize. We use them for diagnostic and therapeutic procedures mostly. Yeah, so talking about capsule endoscopy, it looks more like this. You swallow the capsule, then it will move through your digestive tract. Then you wear a recorder from outside. The recorder has sensors. So it is these sensors that capture the images, then the doctor can be able to review them after. It has different advantages. It is painless, no need of sedation like the other two. It can reach the small intestines without surgery. Then the doctors are also able to get accurate diagnosis. Talking of flexible and rigid endoscopes, some of the components they have quite similar. So starting from the tower, on our left side, we have for the flexible endoscopy, then on the right, we have the rigid one. So like I said, they both have cameras, so we shall need monitors, and it is on these monitors where we can see what's going on inside the patient. They usually both have video recorders, but video recorders are more common in the rigid endoscopes, whereby you can choose to print out immediately what you've recorded. Then for the flexible ones, usually we employ some other softwares whereby I need to first do a report, attach the images, something like that, write the diagnosis and everything. So they both employ carbon dioxide insufflators, but it is also very common in the rigid scopes. This is whereby we are able to we employ the carbon dioxide insufflator for the rigid ones because we need to expand the cavity, the area of operation where we're working, so that we can visibly see or increase on our field of work, and we are able to do the operations very well. It is also there in the flexible ones, but it is not so common. It's kind of a preference for different doctors, but still, if you don't have the carbon dioxide insufflator on your flexible tower, it's also very fine. We have processors for both. Processors are majorly for processing the images from the cameras. Then we have the light sources, which provide the light, because inside is very dark, so we need the light to see what we are doing. Yeah. Still, we have other peripherals. On the rigid endoscopes, we have the camera head and the light guide cable. These are the ones which we connect on our actual scope. And the camera head is the one that sends the signal to the processor so that we have an image on the monitor. Then the light guide is for giving us light on the scope. Then on the side of the flexible ones, we have a suction machine. It's very important because inside of the cavity or inside of the lumen, we have, for example, during preparation, the patient takes some drugs which are in fluid form, and they tend to stay inside. And when we're doing the operation, when we're doing the treatment, we tend to suck them out. Also, we tend to suck out any other fluid that is inside the cavity. So we also have a water irrigation pump. This one majorly is for cleaning the lumen. Yeah, so that especially if you see a point of interest and you want to get a clear image or you want to get a clear visualization, you can use the water irrigation to spray on that area, and you get a clear image. So on the flexible one, we also have ultrasound processor. This is also not very common, but this is where now the flexible scopes tend to employ the camera plus the ultrasound technology. So we can use this to visualize areas like the pancreas. For example, if you're in the stomach, you can be able to visualize the pancreas, the liver, things like that. Yeah, so telescope is another name we use for rigid endoscope. Some of the parts is the eyepiece where we connect the camera head, the light post where we connect the light guides. It has an assembly of the rod lens, the objective assembly, and the spacers. These ones form the camera, and we are able to visualize the image on the monitor. We have light fibers, of course. These are also for the image. These are also for lighting when we are inside the patient. So they have different angles. That means they have different types. So the field of view can vary from one telescope to another depending on the doctor's preferences. They employ instruments like trocars, forceps, hemostatic clips, electrosurgical devices, and so many others. And this image right here is an example of how we use how we employ the different instruments. The trocars can help us access inside the cavity, so we puncture the patient's skin from outside through the trocars. Then you can push the telescopes and other instruments through the trocars. Yeah, so flexible endoscopy. This one is going to be our major area of focus because for it it's broader, and I think it's what we shall interact with mostly in our field or in our hospitals. And it's very important to get to know how it looks like, then also get to know the different parts. In that way, when we get to know the scope, we can be able to know how to handle, how to service, and each and everything like that. So we have different sections, and by the way, this cuts across all scopes. The design might change a little, but the parts will stay the same. So we have what we call a video connector. Video connector is this, and it is the one we connect in the processor. So the video connector side is where you'll find that it's the area where we connect all the other parts that are going to be connected on the scope. For example, this section here of the gauze lens and the air pump, this is now in the light source. So this is the area that's going to enter the light source. Usually there is a cable for the processor. It runs from the scope up to the processor. Then we have the air supply and the water supply. These ones are connected to a water bottle. Then we have the suction connector where we connect the suction machine. And this scope doesn't show it here, but we have another port for the water irrigation pump. So yeah, this is the video connector. We have what we call the control section or the operation section. This one mimics the name because it's where the doctor does each and every control on the scope or when they're inside the patient. So it has buttons. These buttons they are related to the image. So you can freeze an image, you can capture an image, you can record, you can magnify. Some scopes go further to an extent that they have the functions of different filters for the image, depending on what the doctor is interested in seeing. We have the control knobs. Control knobs control what we call the bending section, this one, because it is the direction of which the remaining part of the scope follows. So the controls, we have left, right, we have up and down, and they have different locks. This is the lock for left, right. This is the lock here for up and down. And these ones, they have different angles depending on the different scopes. And the doctors really know how to use them. All we need to know on our side as biomeds is if they are achieving the angles they were set to when the scopes were built. So we have different valves also. We have the suction valve. This one controls the suction machine or the suction functionality. We have the air water valve. This one controls the air water, which you're going to use on the machine. We have what we call the instrument channel. This one right here. Instrument channel has is where all the instruments we're going to use on the machine are passed so that they come out from the distal end right here. So we have what we call the stiffness control. This one controls the flexibility of this scope. There are areas where the doctor wants the scope to be more stiff so that it can pass a certain angle. Then there are areas where the doctor wants the scope to be more flexible so that it can navigate better. So this is the functionality for it. It's not in all scopes, but it's very common in what we call colonoscopes. We're going to see them after. The insertion section, this one here, follows the bending section, and it's just flexible. And where the bending goes is where the insertion follows. It's insertion section because this is the area that is inserted into the patient. Then we have what we call the distal tip. Distal tip, I consider it the most delicate on the scope. Why? Because it has what we call a camera. Some people call it the objective lens. This is very delicate, and if not handled very well, the repair of the camera is close to buying a new scope. So on the distal tip, you'll find that we have the camera, we have the two light guides. These ones just transmit light all the way from the processor or the light source up to the light guides until the light comes out. We have the air water nozzle. air water nozzle follows the valve, also follows the bottle which we connect this side, plus the pump which is in the machine. We have the water jet nozzle. This one is connected to the irrigation pump. Then we have the instrument channel, which is the same as the suction channel also. We are going to see why. So the instrument channel, this is how it works. When the instruments pass through here, through the biopsy valve, they come out in this way, so that inside, for example, if we have a polyp and we use, this is a snare, it's an example of an instrument. We are able to cut out the polyp, take it to the lab and check if it is cancerous. Yeah, so the connection side, we have different connections depending on the technologies. Maybe something to note, I'm going to use majorly examples of Fujifilm because at Medic Uganda Limited, we have a contract with Fuji and we majorly deal in endoscopes of Fuji. Yes, so we have different connectors. We have this one whereby we connect the light source and the processor. We also have this one whereby we're only collecting the light source, then these machines communicate with the cable from behind. We shall have a look at that. So inside the scope looks like this. It has so many going on. It has the channels, then it has the cables for the camera, for the light guides, for the stiffness of the scope, and each and everything like that. It has the different channels, the air, water, the suction, the instrument, the water jet, each and everything. So the channels look like this. We have the suction channel as the valve, then comes out from the end. Then we have the air. The air, remember, it's from the light source. Air flows controlled by the air water, comes out. Same thing for water. If you follow the water channel, these ones come out from what we call the air water nozzle, because somewhere, somehow, they connect and they come out from one area. Then we have what we call the water jet, which just flows straight up to the outside. Remember, I said the air water channel is for cleaning the water. The water functionality is for cleaning the camera and this image. The water from the nozzle cleans the camera. Then the air is for separating the lumen so that the scope can have access and it can flow very well. Yeah, then the water jet, remember the water irrigation pump. This one, it's for, like I said, it's for clearing the endoscopic view, cleaning the lumen so that you're able to see the area you're dealing with and you don't miss any diagnosis. Yeah, so we have common types of endoscopes. We have the gastro. This one works in the esophagus, the stomach, and the duodenum. The types come from the names of the scope. So we have a colonoscope, which deals with the colon and the rectum. We have a bronchoscope. It's for the airways and the lungs. We have a duodenoscope. We use it majorly in ARCP. And ARCP, we are dealing with the bile and the pancreatic ducts. We call it duodenoscope because it stops in the duodenum, and this is where we can access the bile duct and the pancreatic duct. The technology I talked about for ultrasound, not very common, but you can meet these scopes in big hospitals, whereby we employ endoscopy and ultrasound, and we're able to do things like pancreas. Instruments, we have biopsy forceps, we have dilators, stents. There are so many band ligators, injection needles, guide wires, etc. And the design of these instruments looks like this. Someone might wonder how the instrument is able to go through the scope. So the design is like this. So through the instrument channel, you can pass the instrument and it comes out from the tip of the scope. Yeah, so let's go to the preventive maintenance. As we are doing this section, I want us to acknowledge or to keep it in our mind that when it comes to endoscope, when it comes to flexible endoscopy, it's maintenance, it's handling of the scopes that we focus on majorly, because if your scopes are handled very well, you'll have they'll rarely break down and they'll last longer, they'll save you repair, they'll keep patient safety and the user yourself. So here we shall focus more on proper handling, cleaning and sterilization. And we'll go ahead and say that we rarely maintain the scopes, but when we do, we can do it semi-annually. And this requires qualified personnel to do it. It's not everyone that is supposed to handle scopes. So for the case of the light source and the processor, we can do the normal service, dusting of the instrument. You can also monitor the working hours of the lamp for the processors which have lamps. Yeah, usually the machine tells you. Then for the camera system maintenance, this is also more of inspection. You just look at the display on the monitor. Is it still okay? Is the camera lens clean? Is it not scratched? Is the image still as when you bought it? Then we have those processors that do white balance. It's a technology that is wearing out, or most people don't. Some brands don't use it, and that is what we call white balance, whereby you ensure that what is white is white, what is red, things like that. So like I said, when it comes to scopes, we focus more on proper cleaning. We call it quality reprocessing. And why do we do it? Because we want to prevent defects and misuse. We want to save on the repairs. We want to reduce on the breakdown time, and we want to keep the patient, the user, and the site itself safe. So reprocessing procedures, we have a procedure we do at the bedside when we are done with the treatment, or when we are done with the procedure. That is pre-cleaning. This is where we clean on the outside of the scope and we flush water into the channels. Then we take the scope to the cleaning room, where we do what we call a leakage test. This is very important. We are going to see why, but it is it's an important task we do when it comes to reprocessing of scopes. So after leakage testing, we can do the manual cleaning. Here we use an enzymatic detergent. Then we can rinse off the detergent. Then we do the disinfection, whereby we soak the scope in the disinfectant 15 to 30 minutes. Then we rinse off the disinfectant. Then we dry the scope, and the scope is ready for use, or it's ready for storage. So as long as you maintain this procedure in the right way, your scope can run you years and years without any breaking down. Yeah, so I talked of the leakage test. This one is very important, and like the statement says, that it's a crucial process to ensure that the scopes are watertight and safe for use, preventing patient contamination and costly repairs. So leakage test helps us to identify if a scope has leak, if it has a leak, because remember, the scope is dealing with fluids, the cleaning has water, and we have seen that inside the scope we have what we call cables, we have wires for the camera, we have light guides. If this water escapes into the scope, it's going to damage these areas, and they're going to turn into what we call major repairs. Major repairs are those repairs which are related to like the camera, the light guides, things like that, which are sophisticated. So we have two types. We have the dry leak test, we have the wet leak test. Dry leak is each and every facility or each and every tower of a scope should have a leakage tester. So before you dip this scope into water for cleaning, you first do a leakage test, whereby you connect the leakage tester onto the scope. You insufflate the scope until, this is an example of Fuji. So in Fuji, we do up to 20. Then you observe for 30 seconds. If it drops up to 15, then there's a big problem, because now there's a leak on the scope. But if it stays still, or it drops like 2 or 1.5 in 30 seconds, usually that is okay. So what happens is that if you pass the dry leak test, you can go ahead and do the wet one. But if you fail the dry one, never dip your scope into water or any fluid. So the wet one is where you just carry your scope, dip it in water, then you try to move the angulation, you try to move the scope around, and you see if there is any leakage you've missed out. Yeah, so during reprocessing, we have different approaches. We have the cleaning, which is by the chemical, that is the enzymatic detergent, and it's the one we use. Disinfection, you can use the disinfectants listed below, Sterenios, Sidex, Opa. There are so many others on the market. So any endoscopic disinfectant you can get, or that is recommended by the brand of the scope you're using, that's very okay. Then sterilization, usually we recommend the gas sterilization, because it uses low temperatures, but we never autoclave the scope. Yeah, so that being said, we are going to go to the common issues. And like I said, when it comes to scopes, it's maintenance, it's proper handling. And if you're able to handle the scope very well, you're not going to get these issues we are going to look at. and therefore you're going to save yourself from any repairs. Repairs are super expensive. Yeah, we have common problems. We have problems which are related to the air-water channel. That is, can be a nozzle blockage, can be the valve of air-water. Sometimes when the suction overpowers the pump of the processor, it's also an issue. If you don't connect the scope very well, or if the tank is not closed very well, water tank is the water bottle we use on the tower. It's not closed very well, you're going to find issues with your air-water supply. We have the image problems. These are related to the camera lens. Sometimes it's the connector. Sometimes it's the connector of the light source, and rarely, but sometimes also the signal cable. Yeah, suction problems are not common, or they're easy to identify, and they are majorly two, because suction is just one complete tube running through the scope, just that it has a control valve somewhere. So it's either your machine, your suction machine you're using, or it's the suction valve that is worn out, or its O-rings are no longer working very well. For the brightness, you check your light source. Sometimes it's the light guides themselves. Maybe even the scope is connected poorly. And like I've said, sometimes it's the broken light guides. So, for example, in this image, there are supposed to be two light guides, but one side is not working. This some people categorize it as one eye. So this is a problem when it comes to scope. You're going to have shadows when you're inside the patient, and you won't be able to see very well. Yeah, so let's look at live examples. These examples are examples that have happened to me here in Uganda. So I use these ones because I know they happen to some of you guys there also, and sometimes you don't know how to face them, and sometimes you don't know what is causing them. So one of the common ones is the cracked camera. Cracked camera forms a shadow on the camera lens, so your image on the monitor is going to have a shadow. This is really discomforting because, like I said, the camera is your eyes when you're inside the patient. What usually causes it is poor holding of the scope. If you leave the tip, like I said, it's very delicate, it hits the ground, it's going to form such small cracks on the camera that appear very big when they are on the monitor. We have the scratched camera. Scratched camera is not usually it's not so common, but it happens, especially when you're cleaning, and you're cleaning adapters have metals, or if they are worn out, and you're trying to scrub on the camera, and you put a small scratch on the camera lens. So these scratches are so small because these are magnified images, but they appear very big, or they cause really discomfort when they are when you see them on the monitor. Yes, this is the right way we handle the scope. We handle the operation section and control and the video connector on one side. Then we handle the scope tip alone in the other hand. So this way we are saving the camera, and also we are keeping it away from anything that might scratch it. Another way we can prevent the scratches on the camera lens, if we use a soft brush, usually still new, and it doesn't have the bristles coming off. Yeah. So another common problem, very, very common, is the nozzle blockage, the air-water nozzle. Air-water nozzle is usually blocked by if we clean using gauze, or if our water is dirty or our cleaning is poor, we shall have the air-water nozzle blocked, and you'll have your camera blurry like this. So what causes the blurry camera is usually now, remember the nozzle is supposed to clean the camera, but now it cannot. And when you enter inside the patient, you're going to have all the dirt, all the dirty fluid inside the patient settling on the camera, and you won't be able to see. Some doctors choose never to do a procedure when their air-water nozzle is blocked, for the safety of missing out any problem that may be inside the patient. Yeah, so one way to prevent this is like same for the camera, we use a soft brush and we scrub on the nozzle. Yeah, what we don't use is we don't use tap water. When we are cleaning, we use distilled water, because tap water, when it's drying, it might form particulates. We use We don't use cleaning material for a long time because they start to lose, to cause, like for example, they can start having lint like this gauze. Then we also don't use gauze. Some gauze comes like that when it has lint. So also that we don't use gauze that have lint. We replace it with lint-free gauze. Yeah, so another thing we do is we do the inspection of the nozzle each and every time we are going to use the scope. So you test the water, you test the air if they're working very well. Yeah, we have the instrument channel damages. That is, we have damages which are caused in the instrument channel. These are usually by the instruments themselves. What happens, an example number one is if you open the instrument when you're inside the patient, and when you're inside the scope and it punctures the channel. For example, this is an injection needle. It was opened before it came out of the scope, so to pierce the channel. When you open, this is a biopsy forceps. They opened it before it came out of the scope, also punctured the scope. Also, when you overbend the scope, when you're passing the instrument, it is going to puncture the walls of the channel and it's going to cause problems. Also, the cleaning adapters we use, they usually have safety at the tip, so ensure that the safety is on before you go ahead and use the brush. So how do we tell that we have a problem in the instrument channel? We shall have bubbles coming out of the instrument channel when we are doing the wet leak test. So this is an indicator that our instrument channel is punctured because now the water in the benzene or in the trough is replacing the air which was inside the scope. Yeah, so prevention, the very first one is we close the instrument when we are passing it through the scope. Next is to ensure that we hold tight, the instrument doesn't open up before it passes through the scope. Then number three is you make sure the scope bending is not so sharp so that the instruments can pass smoothly. Then the instruments you're using for cleaning should be with the safety or with the sharpness absorbers. Yeah. So another thing that can cause water invasion into the scope. Another example is this one, whereby this usually happens when the scope is now punctured from the outside. When does this happen? This happens majorly when I'm cleaning the scope and I also cleaning other instruments in the same basin. I'm cleaning the scope, so they can puncture the scope. And this you can see it, especially during dry leak. Then you pass a soapy cloth all over the scope, you'll see these bubbles. So this can be identified during the dry leak test. Yeah, so what happens when when we get punctures on the instrument channel? We shall get shadows on our images, these such stains. Also, we shall get distortion in the image quality. So these are also live examples. They have happened before, so let's be careful with that. Then another problem is the video connector. Video connector this is on the processor, and these are the pins of the scope. Usually, remember when we are cleaning the scope, we dip it in water and each and everything. So, but the video connector for the scope has what we call the cover, this one here. So if this cover is open during the cleaning, you're going to find water is going to enter here. It's going to stay on the pins and you're going to connect the scope. In the processor is going to provide power in this area, and you're going to cause shorting of the circuit boards inside the patient. Your image will be showing like this. Anything that is related to the camera, be it the connector side, be it the distal end, the repair is expensive and it's going to be super costly, almost to buying a new scope. So never open your cup when you're inside the cleaning basin or when you're washing the scope. And also before you connect it to the processor, make sure you dry out all the areas and everything is dry before you do the connection. If not, your image will be displaying like this. Yes, so what has happened is that different brands have tried to avoid this problem, what to do to make designs that can prevent this problem. And what they are doing now is they're designing watertight connectors. These ones, they don't need cups. When you're connecting them, all you do is you just dry them off, then you can connect them into their processors. This is new technology, and some people have employed it, some people are still on the old one. That's why I needed to show you what is happening with the old scopes. Yeah, but this is the new technology. Yeah, we are doing out with pins. We are doing such connectors whereby you just wipe them dry and they are ready for use. Yeah, so I've been speaking about repairs, and the thing with the repairs is that since they're expensive, even the endoscopy workshop is expensive to set up. So most people, or more, there are very few endoscopy workshops across the different countries. What we do here, or what most people do, is they ship back to the manufacturer. So we have what we call the major and the minor repairs. Minor repairs are those that they can be on the nozzle, it can be on the bending section, they can be the distal tip cap has fallen off, things like that. The angulation is distorted. Those ones that don't take much time, those ones that don't affect the camera, those ones are minor repairs, and they're usually external on the outside of the scope. Then we have what we call the major ones. These ones really affect the scope internally. For example, this was water invasion. Water entered into the scope. It settled. It formed. This is must have been the disinfectant. Damaged the circuit boards. Also damaged the body of the scope. So this one is really big and it is really worrying. So anything to do with the camera, anything to do with the light guide, the insertion tube, those are expensive repairs, and yeah, we should take note when we are handling scopes. So it uses specialized tools, by the way, to do the repairs for scopes. So it's not like you pick a star and you start opening the scope. Scopes have different jigs and different tools you use to opening them, and they differ depending on the brand of the scope. So that's why even setting up the workshop itself is expensive. But if you can handle the scope very well, you won't find major issues with the repair, and therefore you won't have many issues with doing the repairs or downtime. So that being said about scopes, we shall look at the planning and procurement. Planning is this is before I buy my tower. What do I need to take note of? Before you go ahead and buy, you need to take note of the equipment maintenance. Is it available from the person who's supplying to you the tower? Is it do they have schedules? Do they have the capability to do so? Then another thing is, do they offer trainings like for the staff and also for the engineers? And also, in case for the future needs, I need spares. I have a broken down scope. Are they able to provide for me solutions for this? So this is very key when you're planning for endoscopy tower, because remember I said handling is key. So training has to be there. They have to train your users. They have to train your biomates. Then procuring, you take different factors into consideration. First and foremost, which type of endoscopy are you interested in? Are you going to do gastro and colonal? Are you going to do ERCP where you need a duodenoscope? Are you going to go further and do broncho? This is one key area to look into. Then which equipment works for you? Different brands have different features they are good at, and for example, if you have to look at Olympus, it's durable. If you look at Fuji, that's the best camera. If you have to look at Pentax, it's also competitive up there for durability, things like that. So that being noted, you also need to know which scopes do I need, like how many scopes do I need depending on the traffic of the patients I have, because it is recommended to do at most 6 scopes a day. So if you're doing more than 6 scopes a day, that means you need another scope in order to reduce pressure on the one scope you have. This will help you do less of handling on that particular scope. It won't get, I'm going to say, tired, and therefore it won't be facing problems of breakdown. So I've talked of after sales, that is the technical support, the trained engineers. availability of spares and the repairs, and also the capability of doing the user applications training. Very key. So when we are planning, I've already explained this. You identify the scopes you want, the procedure volume, maybe the staff training. Your supplier has to offer staff training, or you as a supplier, you have to equip yourself with the training straight from the manufacturer, so that you are able to represent the brand very well. And budget allocation. I don't recommend doing rentals for scopes because different people handle scopes differently. Then equipment selection, I've also talked about this one. What do you want? What are you looking at? Are you looking at image? Are you looking at maneuverability? Are you looking at durability? What are you interested in? Because this is where you do the research on the different brands, and which brand will give you which features you're looking for. You also look on the market if there is a supply for the different instruments. The air water valve, these ones you can get from the manufacturer or from the person representing the manufacturer, the biopsy valves, the air water valves. Cleaning solutions are common. There are many on the market. Different suppliers have different cleaning solutions. Then the availability on the market, how available are they? Then you can go ahead, for example, if you're handling so many scopes, you can go ahead and equip yourself with what we call endoscopy washers. Endoscopy washers do the whole cleaning of the scope for you. That means the scope is not going to be handled with the people. It's not going to be in people's hands very often, and therefore you're minimizing the poor handling of the scope. Then the drying cabinet. This is very key. Usually we equip them with ultrasound. Not with ultrasound, we equip them with ultraviolet so that they have, we can kill the germs. So drying cabinets, if you can manage, you also equip yourself with one. Yeah, so procurement, when you're procuring the scopes, look for reputable suppliers. Reputable suppliers usually sign contracts with manufacturers. Manufacturers also want people who can handle their scopes very well. Like, you're representing a brand, so you should be able to represent the brand very well. When you get the reputable suppliers, you can get their RFQs. These are the quotations. We try to weigh and see which one favors you, which one has better paying terms, which one will work for you, and things like that. And then you can go ahead and negotiate pricing, delivery schedules. Training has to be there. Ensure that there is always training, whoever is supplying endoscopy, because it is very, very key. And then you can look at the maintenance agreements. Yeah, talking of risk management, we have some common risks that happen in endoscopy, or that are considered very common. We have the infection control. We have the equipment damage, then we have the user errors. Infection control, this is usually how is your area of operation? How do you disinfect? How do you clean? Like, generally, how do you control like the infections? Yeah. Then equipment damage comes back to handling. Is your staff equipped with knowledge of how to handle scope and everything? Then user errors, same, comes back to handling. So mitigation, we can do trainings. This is for user errors and equipment damage. The robust cleaning and disinfection protocols can help us mitigate the infections. Then regular inspections for wear and tear. Like, you keep monitoring your scopes, their performance, how are they doing, so that in case of anything, any deviation from normal operation, you can be able to notify your engineers and you handle the problem before it becomes even bigger. Yes, that being said, that was my last slide, and I thank you guys for listening. And sorry, I guess I had somehow I had some noises in the back, but yeah, I hope I didn't miss out anything. So yeah, thank you guys. I'm going to request Victor to come back and we handle I think the questions and answers. Yes,
all
thank
right.
you.
Thank you, Engineer Jimmy, for that wonderful presentation. And I do think it was an exciting presentation, to say the truth. So for our audience, right now, it's time for questions. If you have any questions from the on the presentation, please just type your question in the chat, or if you want to speak, just unmute yourself and just raise your hand, and I will ask you to unmute yourself and speak. All right. So firstly, there is a question in the chat from Gabriel. He's asking, in terms of repair, is it possible to replace the coating on the bending section of an orifice endoscope when the coating got worn and peeled off?
Yeah, the coating on the bending section, yes, you can replace it, and it's considered a minor repair, because all you do is we have what we call epoxy on the scope. Let me see if I can get an image that can show epoxy for the scope. Yes, this black, this black, we call it epoxy, though it's medical graded. So you disconnect, you cut off this epoxy, tear off this this torn rubber, then you can fix the second one, the next one, then you can put the epoxy back. I'm just going to summarize the process, but it's more than that, because we first tie the bending rubber before we apply the epoxy. But yes, it is very possible, and it is not so expensive.
All right. Thank you. I hope that answers the question. If you want more clarification, you'll come in. But there's also a hand from Adias. I think I'll just ask you to unmute yourself and ask your question.
Sorry, Victor.
I was saying there's a hand from Adias, so I'll ask him to unmute himself and ask the question.
Thank you, Mr. Jimmy. I hope you are hearing me. Eh?
Yes, I can.
Now, I have a client who happens to have an endoscopy machine, bland AVC, XR semen light source, which is Olympus. And he needs a light control cable. Is it possible to get it, a light control cable?
Is that for the rigid scopes or the flexible ones?
The flexible.
In the flexible scopes, we don't need a light cable, unless you're telling me it's for this particular scope whereby it's the light guide inside the scope that is faulty, like the one I showed you of one eye. So one eye is major repair, and
okay, maybe I'm going to send you a photo. I am going to inbox you a photo of that, what is needed.
Okay, then.
Okay, thank you.
Yeah. This is one eye. One eye is major repair.
All right. So there's another question in the chat. This question comes from Gibson. He's asking, in case of equipment failure during a procedure, what would be the various effects to the patient? But before you take that question, Engineer Jimen, because he proceeded by saying, those on iOS, how do we get the presentation? So I guess the best way on that is just visit our YouTube channel, and you'll find the video. It will be uploaded by Monday. It will be live on the YouTube channel, so you'll get the whole session there. With that, Engineer Jimmy, you can answer the question.
Please repeat the question. I didn't capture it very well.
In case of an equipment failure during a procedure, what would be the various effects to the patient?
Okay, that's a good question, but also that is something you pray that never happens. Two things that can happen when you're inside the patient. First and foremost, never pray for the camera to die out. Yeah, because now you cannot maneuver, the scope has made many turns, it has made many rotations, and it can't come out unless you have eyes when you're inside the patient. So what happens is that they may need to even they may need now to do an invasive surgery, whereby now they have to cut the patient and be able to identify where the scope is and how best they can remove it. Another thing is, you never wish for your angulations to break. Those were the control knobs. You never wish for your control knobs to break when you're inside the patient, because now you cannot control the bending rubber. So if you can't control the bending rubber, this one, if you can't control the bending rubber, that means you can't control the rest of the scope. So, and inside, the lumen is not straight. The lumen has curves, and these curves were maneuvered using the bending section. So control knob and camera, these are things, that's why we test the scope before we enter into the patient, because it is really very risky. Also, for the case of the control knobs, you may need to do surgery on the patient. Yes, please.
All right. So thank you for that. There is also a hand from Derek, but before that, I think this is a follow-up question from Gabriel, who asked about the coating. So he's asking, do you offer that service in Uganda, the replacement of the coating or bending section, or the bending section, and how much does such a service go for?
What is the brand of the scope?
Gabriel?
It is an Olympus.
At the beginning of the presentation, I said I deal with Fujifilm. That's why most of my examples were rotating about the Fujifilm design. So Olympus, I cannot help you, but maybe I'll direct you to the people who can help you. So you can reach out to me after.
All right. Thank you. So at this point, I will ask Derek to unmute himself and ask the question. Hello, Derek. If you can hear me, just unmute yourself and ask your question.
Hello, colleagues. Thank you so much for this lecture. I happen to have an endoscopy system that came in yesterday, and the issue with it is okay when you turn it on, the screen displays fine, and the moment the scope is inserted, it immediately disorganizes the display. I've tried the scope in different machines because I have like 3 machines of the same model, and it is fine in every other machine. And it seems the problem is internal in the scope, other in the system. Could anyone be having any solution to that?
What's the problem again?
Like I was saying, when I turn on the system, the display is fine, and it is not disorganized at all. But the moment I insert the scope and lock it in, the display it gets disorganized. Like the whole screen gets disorganized, and you cannot view anything. The words
now you're going to have to check the boards that control the camera, because the boards in the processor that control the image. Another way you can confirm if your processor really has a problem, you get another scope and try to do the same. If it performs the same way or it behaves in the same manner, just know the problem is with the processor, and inside the processor, it's the boards that control the image.
All right.
I hope that helps. Yeah.
That is okay, because I tried with a different scope. I've tried with like 3 other scopes, and it is the same problem. So
yeah, you need to check your processor.
Okay, thank you.
Yeah.
All right. Thank you very much, Engineer Jimmy. But just to kindly ask you, I think for Gabriel, what's the question? You say this. He can contact you. So maybe you can also just paste your details in the chat, your email, so that he can contact you. So I will take 2 more questions. So I have one hand, and then I'll read the question from the chat. So I can see a question in the chat from Tony Gasambula. If my pigtail is spoiled for Olympus, who are the authorized supplier for Olympus to get help?
Say that again, sorry.
He's asking if the pigtail is spoiled for the Olympus model, who are the what the authorized supplier
What
that
is
you can
spoiled?
contact.
What is spoiled?
Pigtail.
That's a brand.
I think this one is also Olympus.
And it's saying what is spoiled on the Olympus?
It's saying pigtail.
I'm sorry, I'm not capturing that word very well.
Pigtail.
Pig,
Pigtail.
yes.
So the pigtail is spoiled.
Yes,
Is
yes,
this,
yes.
yeah, did you confirm the pigtail by testing it with another scope? If that is it, then you need to replace it. Just forward to me contact me and forward to me the details of the mode of the processor you have. I'll connect you to the person who supplied you the pigtail.
All right. Now I'll ask Victor to unmute himself and speak.
Okay, thank you for this opportunity. Thank you for the session too. I have an issue with an Olympus endoscope, a gastroscope specifically, and it doesn't do air insufflation. That's the only issue it has at the moment. Doesn't do air insufflation. I don't know what the issue could be there. Because it does water insufflation, but it doesn't do air insufflation.
Okay. Okay. I know. I understand your problem, and this is where your answer is. You said it does air, but it doesn't do water, right? Okay. In case that's the issue, then the problem is not here at the nozzle, but the problem is within the channel right here. Any of these two. If it's air, then the problem is with the air channel. If it's water, then the problem is with the water channel. It's quite a lengthy process, but it's something we can solve. So if you can also just reach out to me, I'll direct you how we can solve it. It has to do with using the suction machine to try and suck out whatever is inside. You can connect the suction machine here. You close off this side, the water bottle section, and also this area that goes to the water pump. Then you try to suck out whatever is in these channels to come out through here. Yeah, we can discuss it after, yeah, but in a nutshell, it's something like that.
All right.
Thank you so much.
Thank you, Engineer Jimmy. So, personally, I also have a question. I think when you were explaining on the air leak test, I think you said when doing the wet leak test, you have to use clean water. And if I saw the slide properly, it had temperature ranges of 10 degrees Celsius to 40 degrees Celsius. I'm just curious to know if, let's say you do the test at temperatures that are out of that range, what would be the problem?
You do a leak test at degrees? I don't understand the question.
So it's on the leak test presentation, yeah, there. I think I saw somewhere the temperature range, which is +10 to +40 degrees Celsius. So the way I understood it,
you mean this or this?
Yes, yes.
This is for the safety of the scope. Why? Because like we said during reprocessing, we don't autoclave the scope. It's the same thing here. We don't use hot water when you're doing the wet leak test. Your water has to be in the normal degrees. So here they are saying it has to be 10 to approximately 40. This is safe zone. This is safe zone. Anything higher than this can burn the coating on the scope. And that scope is gone. You just need to replace the whole covering, which is a major repair. So this is safe zone. Anything between 10 and 40 of the clean water is okay.
All right. Thank you so much. So just bear with us one more question and then we'll close. There's a question from Bernard. He's asking that he has an endoscope which has an angulation problem. So what would be the cause of this?
Okay, angulation, let me take you back to the knobs. What happens with angulation is this is it's a problem that is caused by, or it arises because of the doctors. What doctors do, for example, when they are inside the patient, I can see an area of focus. Maybe I've seen a polyp. Then I turn my up, then I lock it, and just stay there just to monitor the area. And maybe I'm explaining to my fellow doctors, I'm explaining to the nurses what is happening with the patient. Then when I'm done and I want to move, I forget to unlock. I just turn the knob. What happens is that we call it snapping in endoscopy. You've snapped the scope in that you've forced it to turn until when the knobs are disconnected from the wires that are controlling the bedding section. So the scope has snapped, and it's not a major repair, but it needs when you have the tools and the spares to replace the whole wires, because the wires run all the way from here through the scope and they are controlled around this area. So the snapping happens in this area here, whereby the knobs disconnect from the wires that control the bedding section. It's very common with the doctors, but they rarely admit. But yeah, just know as biomeds, that's a problem caused by doctors.
All right. Thank you so much. And I think that marks the end of our session. So at this point, let me thank you, Engineer Jimmy, for joining us and for having us, for delivering a very insightful presentation to us. We are very glad that we had you on the call. And I also want to thank each and everyone who joined us today for your presence. And let me also ask the audience that if you have any questions or any more feedback that you want to give us, you can contact us through our email. That is the helpdesk@oxygenalliance.org or info@oxygenalliance.org. And for those who would like to individually contact Engineer Jimmy, the details, his contact details are in the chat. Also, for questions, engineers, let me just remind you that we have an app, the DME Ponza. You can actually just ask your questions right there and you get your answers right there. But otherwise, have a wonderful evening. Bye.
Okay. Thank you, Victor. Have a nice time.
Thank you so much.
If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.